Hey everyone! In this video I'm going to talk about causality and the potential outcomes framework. So in general, causal questions are very common in social science research. And this is partly because a lot of policy issues or policy questions are ultimately causal, right? So if we're interested in the impact of a certain policy intervention or some manipulation, ultimately this is a causal question, or it addresses an underlying causal mechanism, right? So in the book or in the chapter that you've read, there are a couple of interesting examples of studies that try to address causal questions like those, right? So one of the examples that you read about is related to the minimum wage, and specifically here the question is, does the minimum wage increase the unemployment rate in a given state? So here, what we might suspect is that, for example, the unemployment rate might increase if after a minimum wage increase. But the underlying question is, would the unemployment rate have gone up had the minimum wage increase not occurred, right? So we're kind of thinking about the counterfactual if in a given state, and we'll talk about this example in more detail in a bit. Ultimately, we're always thinking about kind of counterfactuals. What would have happened had a certain manipulation not occurred? And based on that evaluation, we try to kind of make inferences about the underlying causal effect and the underlying mechanism. Right? Another example for a causal question in social science research in the book is the causal effect of race on employment prospects, right? So one of the studies that is discussed there examines how race affects an applicant's job prospects, right? And that experiment kind of involved sending applications to different employers who were seeking new employees with basically just manipulating the name of the applicant, right? And so, for example, an applicant named Jamal might apply for a job and might see that he does not get an interview, and then the underlying causal question is, how does race affect this, right? So would Jamal have gotten the job if he were white, if the applicant or the name on the application was a different one. So those are two examples in the book that kind of address causal questions, right? But let's talk a little bit more broadly. What do we mean by causality and causal inference ultimately? And conceptually, one thing that is important to kind of think about is kind of differentiating between, on the one hand, the effect of causes, and on the other hand, the causes of effects. Okay, so oftentimes when people talk about causality and kind of think about causal inference, they think about the causes of effects, right? So I see a change in a certain outcome that I'm interested in, and I want to find out, okay, what has caused this change? What has caused this effect, right? But that's not actually what we think about when we think about causal inference. What we think about when we talk about causal inference is estimating and quantifying the effect of a specific cause, right? So we're not finding out, okay, we observed this change in an outcome, and now we're trying to find out what affected that change, but rather we have a hypothesis about a specific type of cause, and we're trying to estimate the effect of that cause. And as I mentioned previously, in these two examples, when it talking about discrimination in the labor market based on race, or unemployment, or the effect of the minimum wage on unemployment, ultimately these effects of causes are, or estimating these effects of causes, or thinking about these what the effect of a given cause is, is always based on some comparison between a factual realization of an outcome and a counterfactual. What would have happened if that specific cause was absent? And so ultimately, our definition of causality is fundamentally based on this comparison between the factual and the counterfactual. And one thing that I want to emphasize in this context is that if causality is ultimately defined based on this comparison between the factual and the counterfactual, it's really hard to think about causation of any type of factor that cannot be manipulated, right? So there's this kind of one kind of mantra in causal inference is there's no causation without manipulation. So immutable characteristics that we cannot fundamentally change are ultimately hard to conceive of as as causal effects or in the framework of causal inference. All right. Another important kind of thing to remember, and that you've probably seen before, is that association or any type of correlation or relationship does not necessarily imply causation, right? So covariation or correlation, two things kind of moving in the same direction together does not necessarily imply that one causes the other. We need more assumptions than just correlation in order to make a causal inference ultimately. Okay, so there are when we think about causal inference and we try to kind of think about the assumptions that are necessary to make causal claims based on our observed data or based on our experiment. There are two main approaches in the literature that kind of talk about these different assumptions, or try to conceptualize how we can make valid inferences or make valid causal inferences. And these are, on the one hand, the causal graph framework, and then secondly, the potential outcomes framework. And we'll talk a little bit about causal graphs. But most of this video and the following videos will focus on potential outcomes, right? But we'll get back to graphs as well. So what is the potential outcomes framework, and why is it necessary, or why is it useful for us to kind of use these potential outcomes to think about causality, right? So as we mentioned, causality is ultimately based on this comparison between a counterfactual or between a factual realization of an outcome and the counterfactual, what would have happened if the cause was absent, for example, or a specific cause was absent. And the potential outcomes framework is basically a way to mathematically conceptualize this idea of there being two potential outcomes. One if the cause was present, and the other one if the cause was absent, right? So here what I displayed here in this table is a summary of potential outcomes for individual units of analysis. I named it a person here in the context of a lab experiment, for example. It could be each participant. But in the other example that I mentioned earlier, when we talked about the effect of minimum wage increases on the unemployment rate, we could also think about these units as individual states which either implemented a minimum wage increase or didn't implement a minimum wage increase, right? And so what we then have is for each individual state a potential outcome, and hypothetically a potential outcome that describes the in our example now, that describes the unemployment rate if the minimum wage was increased here under treatment, or alternatively in the control column, the unemployment rate in a given state if the minimum wage was not increased, right? So hypothetically, if we could observe these two outcomes for each individual state, we could think of the causal effect of this intervention, raising the minimum wage versus keeping it constant, as tau I, so tau for each individual observation. All right, and so we call this individual causal effect tau. Okay. Um, so if in this framework we have two potential outcomes, and the notation here is yi1 for the outcome in the for the potential outcome under after receiving the treatment, and yi0 is the potential outcome in the control group, so without receiving the treatment, so without the minimum wage increase in our case. Then, as I said, the causal effect for individual I, or in our example for any given state I, is, as I said, tau I, and that is defined as the difference between these two potential outcomes. Right? So the difference between the unemployment rate under an increased minimum wage minus the unemployment rate without an increase in the without an increase in the minimum wage. Okay. And then based on these individual causal effects, we can define the sample average treatment effect, or SATE, or sometimes it's also just described as the average treatment effect. But it's important to keep in mind that this is always kind of constrained to the sample to some extent. And that's just the expectation of all tau I. So that's the average of all treatment effects across all units. So across all states, we're looking at the difference between, so it's the average of all tau I, so it's the average of all those differences between these potential outcomes in the control group and in the treatment group, right? And if you remember from last week, we can, this sum we can split up in basically the average value of all potential outcomes across all observations in the treatment group, and the average of all potential outcomes across all observations in the control group. Okay. Is there anything else I wanted to say about this? All right. Okay. So far, this makes sense, right? So this is a straightforward kind of idea what the causal effect then is. But obviously, it's not that easy because obviously there's one big problem, and that problem is that we can't observe simultaneously the unemployment rate in a given state for both cases where A, the minimum wage was increased, and B, where at the same time it wasn't increased, right? And that's what we call the fundamental problem of causal inference. The fundamental problem of causal inference is in this table for where I listed each observation. Where I listed each observation and the potential outcomes under treatment and control, so under minimum wage increase versus not. There are a lot of question marks because ultimately we can only observe one realization of these potential outcomes. And so ultimately, we never know the treatment effect for each individual observation, right? All we observe is the unemployment rate in a state, here in this example, it would be Pennsylvania, one of the states that didn't increase the minimum wage, and we observe the unemployment rate in that state. And on the other hand, a state that increased the minimum wage, in the case of the example in the book, that would be New Jersey. And then we would observe the realization of the unemployment rate under increased minimum wage. Okay, so the fundamental problem of causal inference, again, only one of the two potential outcomes is observable for every one observation. Okay. So ultimately, when we talk about causal inference, what we most focus on is we need a credible way to infer the unobserved counterfactual outcomes, and that's what causal inference is ultimately all about, right? And causal inference ultimately rests on whether these identification assumptions are plausible. And again, just to reiterate, how plausible they are goes beyond, or these assumptions go beyond simple statistical relationships like correlation, and ultimately they kind of they help us to go beyond association and make clear that or kind of determine that there is actually a causal effect between or a causal effect of one independent variable on some outcome of interest, right? So association is not necessarily equal causation unless we make additional identifying assumptions, and unless these additional identifying assumptions are indeed valid and plausible. Okay. Um, okay. So so that's so much about the fundamental problem of causal inference. Of course, the next question is what are these assumptions, and how can we figure out what these counterfactuals are if we can't observe them. And in the next two videos, I will talk about two basic approaches to kind of like fill in these missing counterfactuals, or make inferences about what they or make inferences even though we cannot observe these counterfactuals, right? And in the next video specifically, I'm going to talk about randomized controlled trials and experiments.